So we're in a time of a lot of environmental issues right now. We have floods, we have fires, we have droughts, we have heat waves, and we have water scarcity. And these issues are interlinked. With droughts and heat waves, it dries up the land so that it makes fires more likely. And the fires degrade the soil. So then when the water rains come down, it doesn't get absorbed into the soil and creates these floods. And the floods then erode soil and landslides and degrade the soil so that it doesn't hold the water. So then when the dry season comes, it's a lot worse. So there's this cycle that we've gotten into, and all around the world now, from Australia to Greece to Brazil to British Columbia, in California, like everywhere you look, there's these fires and floods and droughts and heat waves. And I don't think it's been fully grasped by a lot of the public how intertwined these are, and also how intertwined it is with the water cycle, and that we actually can do something about the water cycle, and that's really important to realize that. And the water cycle is, in some ways, a more complicated story than the carbon story. Just like it's like the greenhouse effect is heating it up. And there's so many things going on in the water cycle, from the evapotranspiration to cooling to swales that guide water into the earth. Like, how do we understand all of this? And so we've been actually I brought about 20-something people to try and figure out some of the water principles to kind of condense this story into an easily understandable story. And the idea is we each come up with different versions. So I'm going to show you a version that I think kind of starts to explain the complexities, and in a way that really shows us, oh, we can actually help with these droughts, these fires, and these floods, and these heat waves, and the water scarcity issues. So so basically, the way to look at it is through these 5 aspects. The water flows through the land, through the underground, and up in the air. And the air is invisible, it's water vapor. So we sometimes forget about that, but there's huge amounts of water vapor flowing around up there, and it's having a big impact down below. The water is also shifting the heat around. And so we focused a bit on the carbon aspect of heating up, but water is actually does a lot of things to shift the heat around. With its various abilities to change phases and its abilities to move around. And then water also redistributes the soils and the sediments. And that's key because that's how life grows and where life grows. And water redistributes the pollutants. And then it's also important to note there's a feedback loop between the water, the microbes, the fungi, the vegetation, and the animals. So those are kind of the way, one of the ways to kind of see all the many aspects of water, and how begin to understand how we might use those aspects to help deal with droughts, heats, fires, floods, and water scarcity. So let's start off with the land. So 1A here, the land. So so that you can slow it and spread it, and Brock Dolman coined these terms along with sink it. And it's sometimes you look at a dry creek bed and you might not realize you can actually make those creek beds run longer, because basically if you slow the water by infiltrating into the soil or various things like swales or biomass upstream, you can actually slow the water. So it actually keeps streams running into the drought season, into the dry season. And you could spread it around too, like beavers build dams that spread the water laterally. And so this is actually a key aspect of hydrating. So our droughts don't have to be so devastating. We can keep the plants hydrated. And Peter Andrews in Australia has done a lot of work around this with natural sequence farming. He's shown that we can actually your plants can keep growing even though it's not raining. And so our droughts don't have to be quite so devastating. So this slow it, spread it, and then storing it in wetlands and ponds is key to dealing with it. And what's also interesting is that this is the same way to deal with floods. If we slow down the waters in the upstream, or it goes into the infiltration into the soil, it doesn't all accumulate into these huge velocities downstream and create these huge, it helps ameliorate some of the strengths of this flooding. So these are, I mean, it sounds simple, but they're actually pretty profound, and the impact, and I don't think we really realize it. it hasn't infiltrated in the mass consciousness, the importance of this. And then underground is also really important. If the soil and the wetlands, they can guide the water underground, and the underground actually stores in a cooler place, and the underground can actually keep the water there so it's available into the drought season. And so there's ways that plants can actually use capillary action, other things to actually use some of the underground water. And so the underground is very key, and it's actually like a bank. And so we need to be aware how to fill it up. And so a lot of places like Ogallala, and like in the Midwest, they're drawing up all the aquifers. In Central California, they're drawing it all up. Like essentially, there's ways to actually fill up all these aquifers again, and that's actually the way to actually keep keep a lot of the water for usage. And LA is actually now building a lot of wetlands, some I think maybe $1 billion projects to build wetlands in LA, so that we can actually sink the water underground and then use wells to draw it up, and so we don't have to pipe in water from elsewhere. And the way we've done our modern water system is not, it's clever, but it's not wise, because we've built dams, aqueducts, and farm irrigation systems. So there's pipes underneath our modern farming systems that drain away all the water from the soil out to the ocean. And so that actually depletes the whole continent of water. So that in itself is this huge aspect that we're not realizing that's causing all these droughts and all these fires and all these floods, is that the industrial farming system is draining water way fast out. And it's also related to the dams and the aqueducts, because instead of catching the water in the wetlands, we're catching it in these dams. And then the dams filter it to these farms. But the dams themselves have to release a lot of water when they have these huge atmospheric rivers and floods, because they need to create a buffer. So even though they're supposed to be storing water from wet season for the dry season, they actually lose a lot of that water. So it's not an efficient system. And no one's really like pointing the finger for all the cause of droughts, fires, and floods at the dam, farm, aqueduct system. And so it's important that we kind of point this out and also point at the solutions. And then the aspect of the air, because it's invisible, we don't realize that the evapotranspiration can actually increase the humidity in the air to create rains. And so Milan, who Judith mentioned earlier, was showing how Spain gradually is losing its rains because of urbanization. It's paving over the soil so it can't evapotranspire. And so we have to be very wary of what we're doing with the asphalt and the concrete to, destroy some of these rains, and which also destroys the fog and the dew, which are also helping with environmental hydration. And then there's ways it's transporting. So it's actually this moisture hopping. So the water is actually hopping inland. So if you have a chain of forests, it actually brings in all the moisture inland. But as we destroy our forests, they're actually not allowing the water to come in. So what happens with the water is it rains onto the ground, the forests gather it and pass it up to the air again. And then it's called a small water cycle, but the small water cycle keeps passing the water inland. So this is a key aspect that is also been ignored a lot, like this whole aerial path of the water and how it's actually transporting water around. And if we use it, that's the way to get the water to the farms. And instead we use this dam aqueduct system. But basically, and still a lot of the world, unlike the US, is using rainfall as farming. And so it's having huge impacts on farming in a lot of places where the rain is disappearing or moving around or getting more variable. And then heat is also very key. So, I mean, we're having heat waves all around, like Portland, I think had way over 100 degrees Fahrenheit last year. And we're having these huge heat problems in urban heat islands, because urban heat islands, of course, because we're not letting the water be there. We've paved it over so the water can't evapotranspire. So basically water can evapotranspire and cool the earth. So basically it's shifting. Basically what's happening is the water shifting from, the heat is shifting from the surface of the earth up into the atmosphere. And so that's what we can do. We can shift it up, and when it's up further in the atmosphere, it's not as problematical for life on the earth. It can also transform it. So the sun's rays can be transformed, energy of that rain can be transformed into the latent energy of the water. And then these forests can also create low-lying clouds that then reflect some of this radiation back out to space. And then the water also does stuff with the soil and the sediments, like the more trees you have, that you hold the water so it doesn't erode. And then the rivers can guide the soils. And then the water's also, wetlands can cleanse the water. The microbes in the soil and in the wetlands can clean the water naturally. So we don't need to use as much of these chemical cleansing methods. And then there's a huge feedback loop. So basically with the water, the microbes, the fungi, the vegetation, and the animals, so that there's what happens is called ecological succession, so that if a system is left to organically grow, it actually leads to healthy and healthier ways of using water. So yeah, so that's basically a kind of overview of how we can restore the water cycle and how it can help with drought, heat, fires, floods, and water scarcity. And then I won't go into this, but basically there's a lot of ways to do this. And this is a whole pattern language, all these different methods from swales to leaky weirs to beavers. And so all these methods kind of form a pattern language of how to actually activate these methods of slowing, sinking, spreading, the things in the previous slide. And so these are the different aspects. And so this forms what's called this new water paradigm. And I think it should be named because it's a field that, and so maybe there's names like regenerative water or water ecology. And it should be made up of the practitioners who are practicing on the ground, and then also the scientists. And I think that hasn't been fully merged yet. So in the practice, it's quite a lot the small water cycle. In the climate science world, it's called precipitation recycling, moisture recycling, and also moisture hopping as the water goes inland. And so I think we need to merge a lot of the work that's being done so that practitioners and the scientists work together. And then also this needs to infiltrate the more modern hydrological movement, which are implementing a lot of urban hydrology structures that don't understand all this. So we need to frame it in that language so that we can move this paradigm in. And then the science will help get it into the modern hydrology world and into the governmental legal, laws and stuff. So yeah, so that's my sharing. Thank you.
Wow, thank you, Alpha. Moisture hopping that's a fascinating concept I haven't heard described like that, and I'm very interested in so many aspects of what you're talking about. But I think one of the biggest things I drew from your presentation is the importance, like all of the ways that water moves through the different mediums, right? Air, soil. The one that has the most benefits stacked and creates the greatest buffer for extremes is banking it in the soil, because in the process of doing that, it's not like the water just falls on the ground and sinks straight into the aquifer. It is so productive along the way, and performs so many functions, so many ecosystem services as it does that. And since precipitation is one of the biggest unknowns with climate change, clouds are very difficult to model. Computers don't quite have the resolution and capacity to effectively model cloud cover. And so how much light gets reflected from the earth, and also how precipitation regimes will shift, like where these clouds are induced or inhibited from developing, are some big unknowns. So when rain does fall, we have to do our best to guide it and bank it, as you were saying, Alpha, in the soil. I have a quick story that leads into a question, which is, when I was fresh out of grad school, having studied climate science and society, I was home and I was in town down at Libby Bowl, and there was a woman walking through the trees, and we were talking about the drought, and she mentioned something about, the trees call the rain. And I remember at the time thinking to myself, like, the trees call the rain. What is she like? The trees don't call the rain. That's not true. But, as I've gotten further in my learning about water, she was right. Right? The trees do call the rain. That's what Dee was talking about. And I would love, Alpha, if you could explain a little bit about terpenes and cloud condensing nuclei, and how exactly that process, how exactly does this moisture hopping happen? Something that maybe we can visualize.
Yeah, so forests give off bacteria, and these bacteria concede the formation of condensation of the water, because it allows ice to form around it in the air. So that's a key aspect of how the precipitation forms. And then also sometimes the air in there doesn't have enough humidity to actually create rain. So if you add in the evapotranspiration, that water, it takes it above what's called the dew point. So when there's enough water vapor in the air, it actually condenses. And so the forests help take that above the dew point, and then the bacteria help also condense it and form rain. And then what happens is that it blows a little bit further inland, or it travels somehow, that water vapor that's come down from the trees out further to the next forest, and then it comes down. So it kind of hops. And so there's been models that show that the Midwest drought in 2012 was actually caused by California's drought, because so much of the Midwest water is actually coming from moisture hopping. It hops from California into the Midwest. And that's why earlier this morning, you saw Michael Kravich's slide that as you go in further inland from California, it actually gets drier and drier, because we haven't built that whole forest. It used to be, the US used to be much more forest and much more wetlands. So it allowed that moisture hopping to happen, but now it's been destroyed. And so, we don't realize, most people are not talking that the Midwest drought was caused by California's problem with the water. They're not bringing enough water to pass on with moisture hopping.
That makes so much sense when you think about the size of California and the fact that it's lost 95% of its wetlands. That's a lot of water lost to the atmosphere that would have been evapotranspiring.
And the woman who researched Francina Dominguez, the climate scientist, who did that research.
Would you pop that name into the chat for everybody, Alpha?
Yeah. And I think it would be good. Like, as I kind of went into the literature, I found there was so many amazing climate scientists that a lot of the water practitioners don't know, that are doing really cool research on the small water cycle. Only they're calling it something else, moisture hopping and moisture recycling.